Explicitly, this is not a presentation. We want to find out what people are doing with Lava, what works for you, what doesn't work for you. Bug reports are welcome, workarounds, if you have them, just tell us what you've got, what you don't like, what you do like. We're trying to build a community here and get people helping each other as well. So, as a summary, yes, we know that the documentation still needs to improve. I've spent most of the last month or so reading all the docs, and I'm about to start making some changes.
He's got one set of changes in the yes, you're not showing up on the Cambridge lab, it's yet.
Yeah. So the new dispatcher pipeline gives us a lot of scope for documentation improvements. We're going to have to write a lot more docs, especially as people start migrating over. We're going to be talking about that later in the week as well. What do people want out of Lava? Talk to us. And please talk to us using the microphones. Founders one.
I'd like to test the expansion headers on the 96 course. I'm not sure if it's still standing. Okay, so
One thing.
Yeah,
Sure.
So this is one thing, and basically it broke into any input-output from the board. So it's HDMI, USB, so something that requires the second cord or second something to work. So,
yeah. So are you looking for some? I'm sorry. Are you looking for something that is not multi-node that would be more integrated, or multi-node?
No, it's a multi-node, but probably I'm not sure exactly what does it take to simplify the setup and propose. Maybe it's possible. I'm not sure.
So we are proposing that as well as SSH connections onto boards, we'll be able to support other sort of telnet, netcat type connections onto there. So you'll be able to find those and get whatever output you want from there and interact with those as shell sessions as well. But it's a question of how that I/O is handled, whether you need a new protocol. It's not full shell.
Well, not me. So what I was thinking that it's like connect to boards, run some sort of Linux user space on it, and then test like send from one, receive on the other end. And that's it. So not sure if we can simplify it.
Oh yeah, so we should, because.
So with GPIO, for example, you can hook one, like you can loop between GPIOs on one board, and that works. But with other protocols, it's not that simple.
Sure.
Yeah.
So of course, we spoke a little bit about this in the past. We need to have an HDMI receiver,
yes, exactly.
and that kind of thing. For every output, we need to have something that can receive it and analyze it.
But then how would that work? So would it be another board running Linux or something with the HDMI input, for example, or would that be something else, like the board that the Collabora guys have?
Yeah, I mean, that's what the Collabora guys are doing, is they're running that other board connected to another Linux host, and that's in a part of the multi-node job.
So it's still multi-node.
Yeah, and then they sample the HDMI input. And
I mean, how much do we know about that?
it's actually developed by the Chromium team, Chromium team at Google, and they published the PCB Gerbers, but it's an open hardware build, so we have to have somebody build it, verify it that the software's open.
Right. So
for his use case, are we still relying on tags? So if he had two boards that had...
Not necessarily V2, you could actually specify this in the job and say...
So I guess maybe can you explain how that would work? So here's the ideal, here's the situation. You have one board, you have another board, and they're connected by some interconnect, whether that's just wires that onto the expansion headers. How do you say, okay, I'm going to run this job, but I need to have this particular configuration of multi-node.
We need this particular pair of devices.
Exactly, right.
Well, it depends on exactly what the requirements are for that pairing. With connections between devices like that, you've got to take the local lab setup into account, because you've got to make sure that those devices are visible to each other.
Sure,
Yeah,
but I guess in this
so-
case, so let's just say they're 2 gigabone blacks,
Yeah.
right? Let's make it really simple. So each one has its own serial connection. So you don't really have to worry about connections in between, other than there's a physical connection that needs to be described some way. So when you submit a job to
Yeah.
Lava, you can say, I need this physical setup so that it schedules
You
it
can
on
actually-
the appropriate
You can do something like this with Netcat in a test shell.
No, that's totally not what we're talking about. Is how do you
Okay, so-
get the scheduler to pick that pair
So
of
you have
devices?
like, you have 4 BeagleBone blacks, and you have only 2 with like GPIO scoop.
Then that would be device tags.
Okay, so that is still the
Because
plan.
that's lab specific.
No, it's hard than that. If you could specify
And you
that
have 2
you
pairs.
want a particular pair, but if you don't, if for example you've got half a dozen such pairs,
Then you make sure that the matrix of tags, make sure that you get the right supports. We can't go for,
this is actually where tags doesn't quite solve the problem.
You
There's
have
a
to
lot
have
of
different
maintenance on the tags,
type for
right?
a different pair, right?
If you know that you have pair 1, pair 2, pair 3, pair 4, and any of them will do,
yeah,
but they must be, you must pick exactly pair 1 or pair 2 or pair 3, how do you do tags for that?
so you do that by a combination of the lab setup and the tags. So, for example, in the Cambridge lab, you would do that because you would actually have them in different racks, therefore with different workers, and so because you would assign them on the same worker anyways to make sure you've actually got a synchronous or a visible connection. So there's that level of doing it there as well. But you can still do that through device tags if you need to. You can actually say pair 1, you have tags called pair 1 and pair 2.
Oh, sure, but at that point you're then specifying only one, you will only ever accept one particular pair. This is actually a place where tags
Yeah, so I think
falls down.
I think what Steve's getting at is, so you have of these 2 BeagleBone blacks, you have 4 pairs of them that are linked in this configuration. And so what you currently have is you have to know what tagging pair that you need for a particular pair of BeagleBone blacks to do the testing. I think what Steve's getting at is there a way that I can just say, I want this configuration, I don't care which of these 4 combinations there are, and just hit schedule them. I think that's, because I think it will work with the way you're proposing, Neil, but there's a lot of maintenance in making sure you understand what each device is tagged with, and maybe users still are, especially new users, probably, I mean, that's such an abstract concept for them, I don't know if they're gonna be able to deal with it.
Within a tag,
Yeah, it's hard.
Yeah.
so with the tags, can you also specify roles? Like within the pair, one's gonna have the role, one role, and the other one's gonna have a
Sure,
different
yes.
role.
Yes, given that's on
For this particular case, of course, you would actually want to say you're really testing side 1 of the pair, and side 2 is just part of the test infrastructure.
Yeah, so you have to explain that in your roles, right? Is
Yeah.
you need for the host that you're actually gonna be running the site, driving the I/O, it needs to have a certain tag for that role, and then the other one where you're gonna be receiving that I/O needs to have another tag.
Well, that's just a role.
Right, yeah.
You've got receiver and sender.
Yeah.
Those are the group roles.
Yeah, so I think this is not a difficult problem to solve, I'm just curious if anybody has any.
Yes, it is more difficult than is immediately obvious.
Well, particularly as the idea of it being a pair is arbitrary, it could be any number.
It's not stuck, because you have some sort of nice groups, like, which once you click, you might type programmatically. So you can say, you can call a group whatever you want, you can just have devices.
I am cautious about adding yet another level of complexity. to the
Yeah,
channel.
I think we need to, yeah, I mean, I think what you're proposing would work, the problem is, I think we're starting to run into the ability that there's maybe a handful of people on this earth that could write that job definition and get it to work right, because it's so confusing, so I think, yeah, I mean.
And they're all in this room.
Yeah, they're all in this room right now talking about them. So I think that's one thing.
And they're all second guessing how they would actually do it.
We've all
How they would actually do it.
proposed situations that may or may not work.
I'd be tempted maybe to just say you only actually have one half of the pair in the system, and then some magic then says, right, you've got
No,
this
this
one.
is why.
Yeah.
So where this
is
breaks
why
down.
this is why the Cambridge Lab has done it the way it's done it. Where it says, well, okay, if you're going to have this setup, you have one rack with that group. The next rack over there has a different group. Then the scheduler already knows that for these types of jobs, it has to pick all the devices for the multiple group on a particular worker, which is one rack, because they need to have guaranteed visibility of each other. We can't afford to have them. And
Yeah.
So where this breaks down though is if you've got 4 of these test rigs, which is 2 BeagleBone Blacks each, right?
Yeah.
Now, if you're submitting from a CI job, the problem is that the tags are static. So either you have to send the same tag in the job. So if you, even though you have more hardware, and let's say you schedule 8 jobs,
If you've got groups per rack, then the tags are the same for all the devices in all groups.
and so there's a
As soon as the scheduler says, right, out of this multiple group of 4 devices, as soon as he's picked one, all the other 3 devices have to belong to the same worker. So what demons don't know the device group is actually already implemented as a case of it's because the scheduler already knows what worker it's on. This has already been implemented for the pipeline V2 because of the dumb dispatcher model, because you can have situations like the Debian instance where this device is in Steve's lab, the next device is in my lab. So you can't run multiple between my Panda and his
okay,
can't see each other.
that's interesting. I didn't know that. So what happens in our lab today, where we have multiple dispatchers and people run multi-hour jobs that are across different dispatchers?
Unless the tags, unless the job actually says, I need this, it doesn't get applied. It was put
So it's
in,
only for
it was
tagging.
put in for things like VLAN D.
Okay.
Right, and the dumb dispatcher, because there were requirements where you had to have something, and the secondary SSH connection is put in primarily for that, because if you've got a device that's been booted into a test image, and now you're saying, right, give me 5 SSH connections onto that board, you've got to guarantee the machine, the dispatcher that is making those SSH connections can see the board.
Yeah.
So it has to be, and yes, in the Cambridge lab, all dispatchers can see all boards, probably, but actually that might change. So what we decided was to actually pin it to the worker. And we said, right, the SSH connections coming from the dispatcher to the test image all come from the worker that is controlling the test device.
So of course that's great. It makes it possible, it does then limit you that you've got to have separate.
It's now lab setup as well, so it makes.
Yeah, I was just going to get the point. Is how well is that documented? Because I think that's part of the magic.
It's even
Yeah, right.
Well, none of us realise this.
Actually, it boils down to the visibility of the devices. Whether it's, even if it's distributed, if these devices are visible to each other. So it doesn't require to be on the same worker or something like that, but it depends on visibility. If, for example, geologically, like the dispatchers are separated, if they are visible, the devices are visible, like still we can go for a multi-node job.
And just to summarize that, when there's tagging in place, that's when that rule gets applied, that it only schedules devices that have those tags on the same worker.
So currently, the worker constraint is applied, I'll have to double check, but I think it's only currently applied for secondary SSH connections.
Okay, well, we could extend that to tagging.
Because it has to be for that.
Sure.
And it's being co-opted by VLAN D, because VLAN D has similar requirements that you've got to be able to see critical bits of
So
infrastructure.
again, we need to add this as an explicit feature and ask for when submitting this.
So my only concern is that the tagging might be the wrong field to do this on, because like, so for instance, some of the Juno stuff that happens today, the Android testing, uses a KVM and a Juno, and they're tagged, but they're not on the same dispatcher at this point. Juno's on like dispatcher 05 and KVMs are on 04.
Yeah.
So in that rule, it wouldn't be able to schedule a job. It would reserve the Juno and then look for KVM on that dispatcher. If you can't find one, it's just gonna, that should be a validation error. I mean, so I guess what I'm getting at is that, do we need another parameter somehow to tell it, this needs to be scheduled on the same worker, and not, like, in the case of secondary connections, you'd be able to specify.
Yeah, so at the moment, that's, the secondary connection stuff is a little bit of code in the scheduler that was added for the pipeline support and dispatcher support, and So the hook already exists in the schedule, we just need to expose it to other sources. So
Yeah.
basically, we would, as far as the schedule is concerned, it would treat other jobs as if they were a secondary connection in terms of its device assignment.
Yeah, I would suggest maybe a
What
parameter that we
would you
can
like
put
to
in there to
say?
say this needs to be run, that constraint, right?
What I'd like to say at this point is we can only safely do that in the pipeline V2. We can't keep on messing with the scheduler with the V1 model where you've got remote workers with a read-write Postgres connection because it causes chaos.
Sure.
You've suddenly got asynchronous scheduling and we know what that goes.
Yeah, and I'm just thinking more of when we roll this out to production later in the year, that these use cases exist and some key off the tags, it's gonna possibly cause a regression that we're gonna have to fix quickly because all the Android guys are gonna be at your door knocking on it.
Yeah, but tags are open-ended, so it doesn't matter that the V1 tags that you're currently using to try and pair up enough KVMs with enough Junos for the right number of groups, those tags can still remain. But then you supplement a new matrix of tags that works with the V2.
So
You don't
devices
drop the
in
old tag.
V2 are different than devices in V1.
Yeah.
And you cannot have both on one
Right,
device.
exactly. I'm just saying that I think the tagging, making the tagging, because you tagged a job or you're asking for tagged pairs,
Yeah.
that it automatically decides to schedule it on a worker. I think that needs to be explicit because I can think of
Yeah.
use cases where you might have tagging
Yeah.
across the
Yeah,
dispatches
so
because
it's a hook currently for secondary connections, so that the scheduler knows about that particular use case. That seems expanded out a bit, and then secondary connections will adopt this keyword in their submission, they will adopt that, and that keyword will also then be useful further.
because then it would be easy to validate, right?
Oh, we
If
may
you
well
take it
do it
in and
device
just look
group,
and say, no,
but
can't do that,
we-
sorry,
we-
sure.
Well, no, we've already used device group because device group is part of marketing, so we don't want to do that.
Yeah. So assuming that we do get this hardware, in fact, this hardware is clearly something useful.
Yeah.
Who pays for it? Who gets those made? Because this is clearly something we're going to want to do. Oh, the
Custom hardware
the
for
custom,
the IO.
to be able to connect the,
But for IO for the low speed protocols, we
Yeah.
just need like a piece of wire.
oh, okay.
Yeah.
Well, say
GPI, it's like
well,
GPI.
Oh, sure.
GPI
For the
or
low speed, I'm
license,
saying,
yeah.
if we want to go further, and
Yeah.
if we get from discussion, say if we want to validate HDMI output or
Yeah,
whatever.
then it gets complicated.
Yeah.
You need video capture cards.
Either video capture card.
Poor man's solution for video capture, I've got it rigged up in my lab, is a GoPro camera that's focused on a monitor and will come up and then run OpenCD.
No,
That's so long.
Which you guys don't like sitting at monitors with cameras?
Oh, no, I really loved it, but
We had, Dave,
got over
you remember we had two monitors on the top of the.
Oh, God, don't. In my previous job, I worked for a set-top box company and we had literally an array of, like, I think it was like 36 screens, all with cameras pointing at them. And, oh, it was a mess. You know how that goes.
Like, that's why I said it was the poor man's solution.
Yeah.
Workmans.
So, okay, that's something we should be starting to do this kind of thing, but it's finding the time, the effort, and the money for the hardware to do that as well.
We talk about video capture.
Yes.
So if we want to find the time and the money, I think it could be justified if it was on 96-port hardware.
Well, exactly. That's the exact use case. Yeah.
Yeah.
To do that, it needs to be Linux board that's got PCIe.
But yeah, especially if you're gonna buy a $5,000 HDMI capture card, you're gonna get such specifications. So I think that would be the way to allow. But then that could be reused on other boards, right? It doesn't have to be for that initial implementation would help out.
Yeah, but then again, like hook 1-to-1.
Yeah.
Multiplex them.
Yeah.
Yeah, because the video capture card probably has to be on at the end of the same HDMI cable from that board.
Yeah.
Yeah.
So now you're buying lots of HDMI video capture cards, plus the ones to go with them. Cellos with them.
Monitors looking better and better.
No, they're not. Been there, tried that.
Anyway, that's that point. Do you have any, what else would you like to talk about? Anyone?
No, no, no.
It's actually a question somebody asked me. They want to use Lava, but they don't want to set up the instance. And for some reasons, they don't want to send the board to us. So the question is, if I put the board online, connect the serial port to a host, and I give you the IP address, I give you the username, can you add this board to your instance?
Hang on. So,
I don't think we've ever tried TFTP over a public internet connection.
How about the power cycle?
Yeah, I guess they need the PD, connect to the PDU.
so just to give you some idea, I've got a Debian instance for Lava, which is a remote box hosted by a friend in Aberdeen, right? That box is running pipeline jobs on Panda boards in my lab in Cambridge. So you can submit to this instance in Aberdeen, and the job runs locally in my rack in Cambridge, and that's run on a Qubitruck, and that's on a home dynamic IP setup.
Yeah, but
So-
you're running a worker on that.
Yeah, an instance.
Yeah.
Yeah.
Well, no, you just have Lava Dispatcher installed. That's the.
Yeah, but they don't.
With the new model.
Yeah, I don't think they want that at all. Deal with the config files. What they want to do is
There's
they want to
no-
expose.
That's the thing. With the dumb dispatcher model, this is what we put in. In terms of the Qubitruck in my rack that is actually running these jobs, it has no configuration. It has Lava Dispatcher installed, and it points, and the daemon points at the instance. All the configuration for those pandas is down the wire over there.
But I think this is all about the other way around, if I'm understanding correctly. You just want the device available.
Yeah.
Give us the PDU, sorry, you want the device just sitting somewhere in a rack or on a desk or whatever. You give us information about the PDU and the serial console, and then we integrate that into our Lava instance.
Yes.
Yeah,
That should work fine. I mean, it should work. It's just I would
We've
have
never
to
done it,
wait and see
that's all.
over a public.
Oh, sure.
Yeah, I mean, it would be
And this is
great.
exactly what Neil's saying. It can work. You don't have to go and set up your own instance. He's just saying that we have done this.
Oh, no,
we
we've
know
done
it works.
But you just
Well,
SSH and tunnel the TFTP port, and
Yeah.
it essentially will look like a board on the LAN, and it would just
Yeah.
work.
So I guess the question is, for this, I assume he might have been asking about this so he could hook up his board to the Cambridge lab. What's our position on that? Is if somebody wants to do this and hook it up to the Cambridge lab, what's your thought?
It's one of those, yes, all well and good until it goes wrong.
Yeah.
And then there has to be an understanding that if it goes wrong and it's not available, we can't maintain it. Yeah.
That's true.
Yeah.
Most importantly, it should depend on the device. I mean, not all devices can be.
Sorry.
Not all devices can be tested in the same way. Few of them might have constraint about the network. TFTP maybe
Or
one,
or fast boot, like
or
you know,
fast
you
boot,
have to
and
have
that's the other one.
yeah.
Well, fast boot actually, if the guy buys interesting, then the problem is fixed. But that's not exactly a cheap
It's not a
version.
cheap solution.
No, but it's a working solution.
Yeah.
But still, that's what I was saying. I mean, if the device is a device that doesn't require particular kind of approach, then yes, that may be something possible. Otherwise, it becomes almost impossible without having a dispatcher.
Yeah, so from a sort of lab policy, which I'm just about to make up, point of view,
In 6 months.
yeah, in principle, yes, but we would have to know more about the specifics of the device, and because integrating a device remotely is also going to be challenging, because when we integrate a device a device we've never used before, you end up with it on your desk, connected to your laptop, and you do the integration basically at your laptop, and then you put it in the lab, and then there's another round of the things you hadn't thought of when it's in a larger environment.
It would have to be a known device type is the way to get around that.
Well, it doesn't have to be, but we would have to have some access to it other than just completely remote.
Yeah.
Yeah?
Especially for timeouts.
Yeah.
I
Yes.
think that timeouts has been one of the
Yeah.
most frequent issues during testing.
And timeouts become even more comprehensive
in the V2 model because you've got everything is now exposed as individual timeouts. So you've got to have a handle on exactly how those change when the lab gets busy, the network gets busy, and if you're involving worldwide internet between the actual dispatcher and the device, now you've got even more latency involved. So,
But that can be made known to the dispatcher or Lava. You can tell it, okay, this device is a. You can in some way configure and tell Lava, okay, Lava, this is a device that runs over internet, so you need to take special care on the kind of timeouts you might encounter, or something like that. I mean, that's.
we can do it inside the device dictionary just to, but it's.
So the other thing that concerns me is a little like when we had remote master, is that your connection may not be reliable, and you can't just say ZMQ, because ZMQ is between the dispatcher
Exactly.
and the.
This is why we put in ZMQ, because ZMQ is designed for this kind of latency problem. You've got control at both ends. You can restart and interrupt either end of the communication.
Yeah, but that would involve the dispatcher running and install
but
the remote
this
end.
is what I'm saying, is that your premise is weakened by the fact that you've got multiple connections over this thing which are not fault tolerant, and you're sending it over an extremely high latency, high problem communication.
Fault prone.
Fault prone. So you've got a fault intolerant protocol over a fault prone method. It's not going to work. So you need to factor this in and explain within how you're thinking of setting this up, and come up in advance and say, now look, you can tell from the start that there are likely to be problems with doing this. And it isn't that much burden to actually have Lava Dispatcher installed on a QB truck, just in that local lab.
Yeah.
And now you've got a fault-tolerant protocol over a fault-prone network. And now you're fine, because ZMQ will cope with all that.
And the dispatcher itself is a set almost zero config.
Yeah.
It really is easy.
No.
Yeah.
I take all that on board, but the idea of having no Lava component at the remote end, and
I think
this fault-prone network, I think that's almost. I was
It's
about to
it's almost guaranteed to fail.
state lab policy. We're not doing it.
Yeah.
Okay.
So on a related note to this, the documentation stuff and on this subject, how well documented is this installing just a dispatcher rather than installing the whole Lava? Because not being a Lava internals person, but a Lava user, I don't think that's very well documented.
No.
And that's something I would, because I installed Lava on an embedded board, and the board just oomed all the time and just crashed the kernel. And so, I mean, turns out Lava itself, at least parts of it, I don't know which parts, are consuming piles of memory that are not well suited for an embedded platform. But it sounds like you're running it on a QB truck, but just the dispatcher.
Yeah.
So I'd like to do that too, but I don't know where
Okay.
The memory footprint of the new dispatcher is a lot smaller than
So,
the old one too.
in the old world, on the dispatcher, you had to also have the server and everything else that went with it.
And you have to have all the Postgres libraries and all that.
You had to have so many things that were really redundant, but there for historical reasons. So in the new world, it's far more likely to be able to consider something like that.
But it sounds like Neil's already doing it, right?
Yeah.
So go back to your question of how well is that documented on the
Right.
new dispatcher? Because
So,
it's all just
2016.2, which is the release that everybody was talking about, that Bay Libra was talking to me about. Yes, they spotted problems that we hadn't noticed and which we've now fixed, and we've put in ongoing functional tests to make sure this doesn't happen again. So there was a problem in 2016.2, which is why I got 2016.3 out just before coming to Connect. So the problems that were actually in that release are fixed. Also in 2016.3, Steve and I spent a lot of time splitting out the documentation. So now you've got a help menu instead of just a help link. And you've got V1 and V2 docs. Now so that functionality is there. It's the beginning of a lot more work on documentation. But in the V2 docs, there is a page that goes through about setting up a pipeline worker. Now, the problem is that one or two of the guys at Bay Libra actually followed that documentation with 2016-2 and came across those bugs and it didn't work. But we know the 2016-3 does work, so it's a case of, but yeah, it's the complexity of being in the midst of this migration.
We go from V1 to V2, we're finding out the problems with V2 as we go.
Well, I'm in the same boat because I know I want to move to V2, but I don't know exactly how to do it yet. Right. So that's the, or we've tried it in fits and starts and come across stuff like this and just kind of go back.
Sure.
And trying to run a stable lab and moving at the same time, of course,
So-
could hiss it.
So what we're doing is we're migrating over the next year or so devices in
One by one.
device
Type by
one,
type. Okay.
type by type.
Yeah.
And to begin with, they'll run dual. They'll be able to run both V1 and V2. And as more confidence is grown, and of course, the current CI loops, which are submitting JSON jobs, require V1, but at some point, they will turn tap off those, and then we'll be able to take out, actually just make them purely pipeline devices.
There's a lot of work going to be happening in the coming months to help people do exactly this migration, because we're going to have to pioneer this ourselves. So we're going to be providing worked examples for a whole range of different device types to hopefully to help people work through this themselves. We will be providing help if people are struggling, because we know this is going to be a major change.
And please anybody who's thinking of getting involved in these kinds of situations, get on the mailing lists, get all the people that are working on this on the mailing list and talk to each other on the mailing list. We're still getting mail from time to time coming directly to me, or use the mailing list. And
you're talking about Lava users?
Lava users, the Linaro validation, subscribe to Lava Announce as well, because we do put big announcements up on there. It's very low volume on Lava Announce, it's less than 1 email a month. But Lava users is a continuation of this forum with more people.
So I'm gonna try to move some of the kernel CI stuff that we're doing over to the V2 dispatcher. My concern at this point is that the YAML job definitions are changing the structure. Yeah. And so I guess when do you see that stabilizing, and would think it's a good time to start switching over?
So I did send this out as an email. There's the JSON submission format has appeared stable for the last 2 and a bit years because all the development work has been happening inside the YAML. So we haven't been putting new support into the JSON.
It's stable only by neglect, that's what you're saying?
Yes. Because I know for a fact that when Tyler and I were working on Matt, we were working on V1 dispatching, because that's all we had. We didn't even have the idea or the permissions to go about this massive refactoring. We hadn't got the authority and the time to do it. We were hacking this stuff through with Dave and everybody else on. The JSON stuff was changing quite a lot there. Yep. So you brought in interactive boot commands, that was a massive change.
The dynamic images for fastboot was a big change too.
So changes to the submission format are part of the lifespan of a Lava instance. But what's happened is that the old format tailed off very, very quickly. All the work has gone underneath, and now we're ramping up. So at a point where we are expecting to have incremental changes to the submission format, that's where people are starting to pick it up. So there are going to be more changes than you might have expected previously, because we're doing this migration.
One thing that should help is we've explicitly been talking in the last few weeks about making sure that things are versioned more explicitly. So where it makes sense, you will be able to submit a job using an older submission format, and we will be documenting the changes from one submission format to the next. And potentially inferring things, still being able to support the older ones, and then migrating them internally so they still make sense for the newer code. Again, with an upgrade document, so you'd be able to work out what you need to do to move, say, from YAML format 1 to YAML format 17 over time slowly. It's not going to be perfect. We will miss things. We'll make mistakes. Shout out to what we do.
Well, what we did get into 2016.3 is a improvement to the compression listings, because that was falling into the trap of what we had with the V1, where you ended up with things that weren't consistent across the actual submissions. So we were making, so we had, you had to specify compression for around this, root of S compression for NFS, root of S, module compression for the modules, and we thought, no, that's rubbish. So we did have to change the structure at that point to standardize across there. That can also happen in the future as well, because we'll find actually, we bring in fast model support, we bring in Geno support and Android support, and then we actually look at the overall submission and think, that's not going to make sense to a lot of people when they compare this job with that job.
I guess it goes back to that question. At what point are we going to start the versioning of the YAML?
I would like to get it in from next cycle if there's.
Right.
If you guys do that, I'll switch over right away, because then it allows me to have a stable base as you guys move forward, and I can update.
And that's exactly.
I don't think it's supportable if it's not done that way.
Yeah, I mean, I think
This is why I wanted to get the compression in now.
Right.
And then that'll be the point where we.
Yeah.
Okay.
So you're saying the next release will be V0 basically, or V1 or whatever?
So 2016.3 is effectively, yeah, it's going to be the base of this versioning. Any other structural changes we need to bring in, we'll have to actually have it. I would like to make sure we can do that. The amount of time we've got before 2016.4 release is limited. We might not get into 2016.4, but also I don't know. Just because we've got the same limit on time, I don't expect that we're going to actually have any disruptive changes in the submission format in full. So the versioning, I think, will be based on what we have in 2016.3, and we can bring in this support before the next disruptive change needs to come through. And we'll hold that and hold back on that. So Matt, when you put that compression review, you certainly put something in there that you knew was disruptive. We had to go through and discuss it within the team.
It caused a discussion about doing versions of the scheme.
Let's within the team keep ourselves to that, and if there's any other change that's coming up, even a bug fix where we think, actually we need to put in a new keyword, a new thing, that kind of stuff. We actually think it through and think, no, we've got to delay that. We've got to put that off until we can actually get the other support in and work how it works.
So I've got another question.
Yeah.
So this is my fault, but in the V1 dispatcher, I did the deploy Linaro kernel stuff. I wanted to standardize that interface for kernel developers, because they just wanted to throw kernels at Lava and have Lava do the magic to, like, for example, the fast boot, where it creates those boot images and then sends it to the device kind of on the fly. Now, is that going to be part of V2, or do we have to create our own boot images outside of Lava now that are compatible with the board?
The design goals with V2 are that what you pass into Lava in your job submission is what the board can execute.
So like adding U-boot headers and stuff like that.
Has to be mentioned explicitly in the job. So we have got further around this. We've got you specify if the file you've asked us to download has a U-boot header, and you specify whether the device needs that header added back after we've modified the round bits. We might put modules into it. We might put the test shell into it, depending on how we've actually set it the test job.
Because we have a few. I mean, I'm sure you've seen the code where there's like execute in place, where we have to shift the format of the kernel image around so that the bootloaders can handle it. I mean, there's like a whole bunch of things like that we had to put in. Things like detecting if it's a Z image or U image, and if the platform supports only U images, then it puts the header around it. I mean, you know, there's all these things that we have in the V1 dispatcher that we use all the time in kernel CI. I'm a little concerned that we're going to have to change the build system in some cases for some platforms that aren't, you know, the standard U-boot, or they can't just net boot the Z image. You know, that's going to force us to change quite a bit, and I'm curious what you guys think about.
I mean, in theory, with the move pipeline, there is a lot more scope for fixing these kinds of things up, you know.
Actually, yeah, I guess I don't know how to handle
doing
that.
the preparatory work on the dispatcher that is called, not necessarily with those particular changes,
Yeah.
but with things like hardware packs and with F-locks and stuff like that, all those kinds of problems with the back mounts and these kinds of things, we know that they cause problems when you scale up on any number of dispatches. We've got the evidence to show that there's, you can't argue that we know that there are problems with doing that. So there are limits on what we want to actually be doing on dispatcher. And again, with things like the Cubitruck, if you're going to have Cubitrucks as workers, as dispatchers, you can't expect them to do massive amounts of I/O conversion for every single job.
Yeah, and I think it's not a whole bunch of I/O, it's really just like specialty tools that need to be installed so that it creates the right image format.
It's special, yeah, it's special magic, and the other part of what we wanted from the original design is that people can look at the job submission without understanding Lava, take the same files and throw the files at their device on their desk without the job just falling over for no particular reason. So that we've kept up with the RAM disk stuff, because if you give us a U-boot and tell us there's U-boot, we've got a U-boot thing back on. But equally, that URL, you could just throw it at your TFTP server on your desk and it'll just work. That's what I want for all the URLs to be part of the V2. It's a case of anybody who just looks at the job definition, has a basic understanding of what the different bits of the job definition mean, can still take those files unchanged, throw them at the board, and they get the same results.
Can we just go back and explore, you mentioned F-lock, which we have to use for the Linaro Media Create, but we also have to use that for things like fastboot, because fastboot doesn't behave well when there are multiple fastboot connections simultaneously. How will that be handled in the new dispatcher?
So this is what Central's been working on with containers, to keep things...
Oh, okay, you just asked.
Well, hang on, but the containers aren't going to solve that problem because it's the same kernel that's being used between the containers, and it's a kernel problem or it's a fastboot problem, but basically when there's two concurrent calls of fastboot, it locks up. So even if you do it in containers, it'll be interesting to see if you still see that issue. I bet you I bet $100 you would.
Yeah, you will. You're still going through the same with USB, right?
Exactly, yeah.
It's gonna be-
So we have to look at that. Yeah,
So to be honest, what we really should do is stop patching around that issue and actually try to debug some of it and at least make either a report to AOSP if we think it's a problem with
Start
fastboot,
pushing
or
back web reports when it's clearly...
or try to go to the Linux kernel and say, we're having this problem, here's all this debug information, anybody have any idea? It's a pretty easy problem to reproduce, to be honest.
and D-message just gives you lots and lots of...
No, it's that one error, it's like, error minus 1.7.
1.7.
Yeah, something like that, it's the same one every time. So the problem is, for some kernel developers, they have to have two fastboot devices, which may or may not be an issue.
Yeah.
But I think that would be the hard part, because that's what you need, essentially. You could write a script, as long as you have two fastboot devices that tries to flash like concurrently, then you'd be able to reproduce that problem.
But in my experience, it's not guaranteed that you'll get the problem.
Yeah. It could be after a while, so
Yeah.
I think we need to figure out, I honestly think we should maybe table that for a second and really try to solve this problem, because
It's a bit of a rabbit hole, but it was just, it's another example where F-lock is used for reasons to do with not the tools we're using.
It's 5 o'clock,
Yeah.
end of session. Thank you for turning up, I hope that was interesting. If we didn't get to you and you still have more questions, please talk to us on the mailing list or grab us the rest of the week.
is that DJ Niels?
And yeah, we are expecting to get more and more really cool stuff coming now. We've got the pipeline shipping, and it will unlock a lot of, it'll fix a lot of the problems we've been having. Talk to us. If you have what you think are weird and wonderful use cases that you know the old dispatcher or the old design would never have worked with, even if you think they're totally insane, talk to us, let us know what you'd like to do. We're trying to provide massively more functionality for people.
And in particular, talk to Steve.
Yeah.
It's Steve's role to talk between the different teams and work out where we can have one basic code method that supports lots of different use cases. That was one of the big mistakes that we got pushed into with V1, was we ended up having a custom solution for this team, a custom solution for that team, and then neither solution worked for this other team.
That's a pretty true statement.
Can the V2 dispatcher modify the device tree on the fly?
think all that's not in there. I mean, basically, what they said is what comes in, other than the RAM, it'll unzip the RAM disk and put modules in it, right? And then put a U-boot header on it, but all that custom hackery stuff, that's kind of why I was asking that question.
Yeah, so I want to follow up a little more on that, maybe